In this video, we're going to talk about special right triangles. So the right triangle with a measure of 45, 45, 90 is considered special, and so is one with 30, 60, 90. So these have some very special qualities to them. So if we take a look at the 45, 45, 90, so that just has to do with the angle measures, right? We have two 45-degree angles and a 90-degree angle. Then we have this ratio of the sides that's 1 to 1 to square root 2. So the sides that create the 90-degree angle are 1 to 1. Those are going to be equal or congruent side lengths. And since we have two angles that are congruent, that makes sense that we have two sides that are congruent. So we have x and x here, and then the hypotenuse is going to be the side length, either one, times root 2. Okay, so with this one we have one leg to square root 2 leg. Okay, so this is just showing us kind of how the kind of ratio works here. Okay, now if we have a 30, 60, 90, so again that's 30 degrees, 60 degrees, 90 degrees, we have another ratio, but it's slightly different. So now we have 1 to square root through 3 to 2. So the 1 is always going to be the shortest side. So if you have the shortest side, you can actually get to the hypotenuse of the longest side with just simple multiplication. So if I have the shortest side and I'm going to the longest side, or the long leg here, then I multiply by root 3. So it's the short leg times root 3 to get to the long leg. Or I can go from the short leg to the hypotenuse by multiplying by 2. So it's just a couple of very quick ways. If I have these two types of triangles, that I can move around the side lengths to find different sides. And I don't need all of the sides like I do with Pythagorean theorem. I really only need one side, and I can find all three sides. So let's go ahead and practice this. So for the right triangles below, find the values of the side lengths h and b, round your answers to the nearest tenth. So for this triangle, they want us to find h, and for the second triangle, they want us to find b. So the first triangle is a 30, 60, 90. So this means that if I take the longest side, I would have had to multiply the shortest side by root 3 to get there. So since I'm going from the longest to the shortest, I don't want to multiply. I want to divide. I want to go backwards. Okay, so I'm going to divide by root 3. So it's going to be 4 divided by root 3. So you can see that here. Well, I have to rationalize this fraction. I can't leave it that way, okay, because I can't leave a root 3 in the bottom. So I'm going to multiply by root 3 on the top and the bottom. So this is going to become 4 root 3. And then anytime I multiply a root by itself, I actually get to take that number out. And the reason is because if I went 3 times 3, I get 9, and the square root of 9 is 3. Okay, so I end up with 4 root 3 over 3. They did say round to the nearest tenth. So I do need to make sure that I plug this into the calculator. I'm going to go 4 times, and I have to click on 3 and then click the square root button. And I would hit equals at this point so that you have the total number for the top, and then go divided by 3. So you will end up with 2.3 for h. All right, so let's go ahead and take a look at the 45, 45, 90. So remember on the 45, 45, 90, if I have the leg, either one, I can multiply by root 2 to get to the hypotenuse. So I'm going to go 7 times root 2, which is just 7 root 2. Again, I need to round to the nearest tenth. So I'm going to type this into the calculator, 7 times, and then I have, for my calculator, I have to type in 2 and then click square root. And sometimes depends on the calculator. I think if you were doing this in Alex, you'd actually click the square root button first, and it would give you parentheses to put the 2 in. So you should get 9.9. Okay, so this is special right triangles, the 45, 45, 90, and the 30, 60, 90. So I hope that helped, and I will see you in the next video.